Okay, so it's 2 minutes after 10, so I think we can start. Um, yeah, welcome to the FERRO Open Call webinar. My name is Talent Daddy. I'm from the Helmut Center of Environment Research, which is the coordinator for the FERRO project. So before we start, I just wanted to highlight a few organizational issues. This meeting will be recorded for documentation purposes so that the people who cannot attend today, they will also be able to get this information. And I've also shared our program for today, and I've also shared some important links in the chat. And it would be very nice if you can also let us know in the chat which countries you are joining from. Thank you very much. So just to run you through the program, first of all, welcome all of you. I'm really delighted to have such a big group of people. I'm expecting more people to join, and this is an exciting moment for us here at the for the FERRO team, that today we have the chance to be able to share with you information about this FERRO cascading call, the grants that we are going to give out to participants who will be joining the FERRO team. So to start with, we are going to have a presentation on sustainable restoration by Dr. Olga Tamog, who is also one of the team members, the FERRO team members. And after that, we are going to have a FERRO project overview, and also a presentation on the open call itself. And then after that, we'll have a question answer session, mostly focused on the open call itself. So to start, I would call upon Dr. Olga Tamog to present on sustainable restoration. But just to give a few words about Olga. Olga is an experienced scientist, and I would say she's one of the champions for sustainable restoration, which she's going to explain to us. And this sets a good stage for us for what we are going to talk about today. So I'm happy to have Olga today to present the opening talk here. Over to you, Olga.
Thanks, Talent, for such a lovely introduction. Hello to all lake restoration friends. And I'm really happy to open this webinar today by giving overview about sustainable lake restoration and clarifying how our FERRO initiative and other Mission Lakes initiative projects contribute to sustainable lake restoration. And I would start with defining sustainable lake restoration. The term is used a lot, but it is quite important to understand what we are talking about. About 5 years ago, there was a Lahti Lakes symposium, or generally when we're talking about lake restoration, we often think of eutrophication problem or nutrient enrichment. And about 5 years ago, there was Lahti Lake Symposium on lake restoration in Finland that brought together experts from around the world to discuss the issue of eutrophication and potential solutions. And our research group also presented results there and results of the studies on lake restoration by sediment removal and subsequent sediment reuse in agriculture. And this was in fact our perception of sustainable lake restoration, but there were many participants and it means many different opinions. And here you can see some of the participants and some of their opinions. So we can see that sustainable lake restoration was associated with circularity, with something that provides long-term effects for water quality, sometimes with combination of measures or measures that are environmentally friendly or cost efficient. Seems like many multiple interpretations of sustainable lake restoration. But in fact, when we start analyzing this problem, we will see that these all are pieces of one big puzzle, and this puzzle comes nicely together. we have accelerated accelerated nutrient enrichment of our lakes when we have altered natural phosphorus cycle by starting mining phosphorus to increase food production. And this human altered phosphorus cycle is far too big compared to natural phosphorus cycles. It is leaking, and these leaks are really huge. These leaks lead to huge ecological damage through proliferation of harmful algal blooms, leading to loss of biodiversity, to high greenhouse gas emissions. So eutrophic lakes also contribute to climate warming and also to huge economic losses. And this is multifaceted nature of eutrophication. Management of eutrophication is extremely challenging, considering that there are no possible or there are no drastic changes in nutrient flow to foresee in near future. There are no opportunities to reduce further pollution from point sources and decreasing pollution from diffuse sources is extremely challenging also because of growing population, because of climate change, and importantly also because we have huge accumulations of phosphorus in watersheds from past and ongoing human activities. And as a matter of fact, measures addressing internal phosphorus load are inevitable generally to improve ecological conditions of the lakes. Internal phosphorus lake loading or sediment phosphorus release often represents the main summer phosphorus load to lakes, and it correlates with key water quality variables like chlorophyll A or algal biomass or cyanobacteria. Here you can see some evidence from more regional scale from southern Finland when we have problems in our lakes in Finland. But also recently evidence from around the globe was summarized in this book by Gertrud Nürberg and just published paper. On the other hand, we have been using phosphorus rock unsustainably, and this may threaten our food supply or food security at some point. This is a non-renewable resource that is highly unevenly distributed across the globe, and major reserves of phosphorus rock can be found in Morocco and Western Sahara. So Europe is depending on these reserves and the rest of the world. And the losses of phosphorus are so high already at this stage of transportation of phosphorus from mines to coast that they can be easily detected from the space. But also problem is that phosphorus-rich Western Sahara is in fact occupied territory, and political situation there is highly unstable, which can result also in fluctuating on prices of phosphorus fertilizers. So it's time for the changes, and it's time to close phosphorus cycling, and we can do this by removing sediments from our lakes and subsequently recycle nutrients as fertilizer. In deeper stratifying lakes, we can, for example, reduce sediment phosphorus content by hypoliminetic withdrawal with the subsequent recycling of nutrients as fertilizer. And there are more other options, for example, to reduce phosphorus transport from the catchment by introducing the kind of sedimentation ponds to precipitate phosphorus so that we will be able to remove these nutrient-rich particles and recycle them as fertilizer. And this finally brings me to our full definition of sustainable lake restoration that lake restoration science community came with following Lahti Lakes 21 symposium. So sustainable lake restoration aims at improving ecological conditions of the lakes, but also delivering a number of other environmental and socio-economic co-benefits extending beyond the scale of intervention. And these benefits arise primarily from mainly or to large extent from integrating circularity on nutrient recycling to water quality management, but also from acknowledging the multifaceted nature of eutrophication. So if we achieve improved ecological conditions, then it will also mean that we will likely reduce greenhouse gas emissions from our lakes. We will have increased biodiversity in our lakes. And there is also, what is important here is system analysis. It is important to consider local circumstances, particular lake characteristics in each particular case, so that we will be able to come out with the solution, with the best solution for this particular case in terms of resource efficiency, cost effectiveness, and co-benefits. And this is how we can do changes at local scale that can potentially bring changes also at global scale, at bigger scale. There are a few examples of sustainable lake restoration I would like to highlight today. And first, it is Lake Mustijärvi in Estonia, which is included also as an experimental area in our FERRO project. We have, this was the first well-documented case when sediment was removed to improve the ecological conditions of the lake, but also sediments were recycled in agriculture. And sediment accumulation basins were introduced within the lake during intervention to reduce potential negative environmental impacts and costs of the future interventions. Sediment was proved as a source of phosphorus and other micronutrients in both short-term experiment and also in our 4-year field study. And this field study is still ongoing now for more than 8 years already. But there are also studies that showed that sediment phosphorus is sparingly available for plants, and that is why we're working also on developing best practices of sediment phosphorus recycling. Just to give you a perspective, we have recently carried out a study testing fertilizing ability of 6 different sediments obtained from lakes having high internal phosphorus loading. And in all cases, we saw that addition of sediment improved plant growth, and we also found potential ways or some amendments to improve sediment phosphorus availability for plant growth. Another very famous example to highlight is the example of Lake Ormstrup, that is also a demonstration area in our FERRO project and Future Lakes project. And also in this case, sediment was shown as a source of, as a promising fertilizer. We know that sediment was dredged with a really environmentally friendly technology, or using the smart dredger. And what is important also in the case of Lake Ormstrup, that really comprehensive monitoring was done before intervention. So this potentially will enable us to provide evidence of broader benefits of lake restoration. Another interesting example of hypolimnetic withdrawal approach has been recently applied in Finland. This is Lake Kymijärvi, where phosphorus-rich water was pumped out through treatment facility to precipitate phosphorus, and then was directed through wetland back to the lake. So in this case, developing recyclable filters would certainly increase further benefits of this treatment, of this intervention. To summarize all these examples of lake restoration, we can say that there is still quite much space for improvement. These approaches in terms, especially in terms of reducing costs, reducing negative environmental impact, or increasing positive effect of nutrient removal from the lakes. And this is what we are working in FERRO, and FERRO provides a number of novel tools and number of methods for sustainable lake restoration. We develop measures to reduce both internal phosphorus loading but also external phosphorus loading with the subsequent recycling of nutrients as fertilizer. And we not only design the solutions, we also realize them, we apply them, and we also aim at replicating the solutions. And this is certainly a step. Developing sustainable lake restoration approaches is certainly a way towards sustainable lake restoration, as it was recognized at the most recent gathering of lake restoration scientists at Lahti Lakes 2024. In fact, we have found many possible ways how further support system analysis and how to improve the whole process of lake restoration, how to so that benefits can be evidenced at really broader scale. This joint publication that followed the symposium, it includes really many useful recommendations for lake restoration practitioners. And just because it is an open call webinar, I think that I should highlight at least a few of these recommendations. So comprehensive monitoring and assessment is a crucial step of the restoration process, from identifying problem to finding or to having a solution. And this monitoring and in fact, this step requires big investments also, especially if we are talking about monitoring at broader scale. But scientists have been working hard, and we have already a handful tool or toolkit to support lake restoration practitioners. For example, we have models that were developed to quantify internal phosphorus load and consider this appropriately in system analysis. High-frequency technology for monitoring greenhouse gases and remote sensing technology is developing extremely fast, and this enables both to improve extent and resolution of monitoring. Highly promising technology is sonar or echo sounding, which is very useful to monitor lake morphometry sediments, but also very useful in biological monitoring. And there are also a number of models developed to find out hotspots, so-called hotspot areas in the catchment, to concentrate efforts to and potentially reduce external phosphorus load. So if you identify problem in your lake, try to map additionally potentially related or potentially associated problems, environmental problems. If we're talking about eutrophication, then we also usually meaning high greenhouse gas emissions, and we're talking usually about decline in biodiversity. Just make sure that you take account of this and of this additional problems, and when you plan your monitoring, find out stressors or drivers of the problem and their contribution. Do limnological assessment using cost-effective tools. When selecting between the measures, consider costs, potential to recycle nutrients, potential to reduce harm to environment, and come out with the solution that is best for your particular case. Further, it is highly important to pay attention to accurate execution of restoration or of intervention of the measures. And this execution should closely follow the prescriptions or recommendations of the system analysis. And finally, make sure or assure that the monitoring of reasonable durations. Just because some of the ecosystem components may need more time to respond to intervention and to show improvement, like microphytes, for example. In this case, you will be able to provide evidence at broader scale. And this is basically the formula for success of lake restoration at local scale. And if we have demonstrated success at local scale, we can potentially transfer our solutions and we can have bigger impact. And transfer our solutions for similar conditions. And this is what we are doing, in fact, in our FERRO project, and also together with our great sister projects. So now we are happy to announce that we are ready for replicating our solutions and to work together with you through opening call for associated regions. And here are a few concluding remarks. So just remember that eutrophication is a really multifaceted problem. It's a complex problem that needs also complex actions. It needs input from different actors. Sustainable lake restoration is our generation solution that results at improved ecological state of the lake, but also at delivering socioeconomic co-benefits extending beyond the scale of intervention. System analysis is highly important, so I should make it just take into account your lake characteristics, your local circumstances, so that you will be able to come out with the best solution for your particular case. And in this case, you will be able to demonstrate successful solution. And this demonstration is really vital for upscaling solutions and for bigger transformations. Thank you very much. You can follow us from different channels, and you can also contact us directly by email.
Okay, thank you very much, Olga, for the excellent and comprehensive presentation on sustainable restoration, and also the introduction to some of the work that we are doing here in FERRO. So at this point, I would open the floor for questions to Olga's presentation on sustainable restoration, some things that you might want to understand before we move on to the next session of this webinar. So if you have a question, you can raise your hand through the chat. You can write in the chat or raise your hand, and then we can, Olga can answer, or the FERRO team can answer some of the questions that you might have. I see there is a question in the chat which says, maybe I missed the point, but is the phosphorus status the same in the natural lake and in an accumulation lake used for water consumption? Thank you. I think it's referring to natural lakes and reservoirs, if I understand well. So the question is, the phosphorus status the same in natural lakes and in reservoirs?
Well, phosphorus in natural lake and commonly like used for water consumption. Thanks for the question. I think that I understand this correct. Phosphorus status, for example. Yes, we have, in fact, this is one of the issues we discussed we have potentially different prescriptions, or we guide from Water Framework Directive regarding our phosphorus concentrations or targeted phosphorus concentrations in the lakes. But in fact, we should really consider like local conditions. If there is very high agricultural impact, we cannot really achieve or expect achieving good ecological state. So the conditions can be really, really different, and that is why it is important to consider local circumstances and lake characteristics and catchment characteristics and things like this. I don't know if I replied to your question, but yes. And I can see another question here: is the use of phoslog to log phosphate a sustainable way of restoration? Or it can be, and it can be just because again, as I said, we have to consider local conditions, local circumstances, and lake characteristics. For example, in some lakes, we cannot do sediment removal or hyperlimnetic withdrawal everywhere. And for example, using phoslog can be most beneficial in some circumstances, in some conditions. This can bring to the best solution in terms of, as I said, co-benefits and resource efficiency and cost effectiveness. But there are also other possible ways to precipitate, let's say, phosphorus from the water column, and there are different emerging technologies, emerging approaches, how to recover this phosphorus after to make it to ensure, for example, recycling of the phosphorus. And yes, we have been talking mainly about the technologies that enable to remove and recycle phosphorus, but in fact, we have to. I emphasize need to develop and to improve these technologies, but in fact, we have to improve all technologies. And I think that there are also some phoslog studies to improve this technology or this approach as well.
Are there any questions? I don't see any hands raised. Or okay. In that case, then it seems like there are no questions, so we shall move on. Thank you once again, Olga, for the excellent presentation. So now we will move on to the next part of the presentation, which is I want to talk now about the FERRO project, why we came to this. Olga already has mentioned some of the points about the FERRO, but I just want to give a quick overview before we move on to the open call. So I'll just start sharing my screen now. Just a moment. Okay. I hope you can see my presentation in full screen mode, right?
Yes.
Okay. Okay. So
Yes.
So thank you very much. So FERRO is the full name is Fostering European Lake Restoration by Nutrient Removal, Recovery and Reuse, and Integrated Catchment and In-Lake Solutions. So this work, as you can see, is being done by more than 30 scientists, some of them who are listed here, who are across in 7 countries, which you will see later. So first of all, I wanted to start by the core, to give a background briefly on the core where FERRO was funded. So this was a Horizon mission core of 2023 on European natural lakes demonstration, integrated approaches for protection and restoration of natural lake systems and their biodiversity. So the focus of this core was based on the ecological status of the European lakes. So based on the Water Framework Directive in 2015, they were 16% of the lakes were considered in high ecological status, 40% in good, and 33% in moderate, and 11% in bad and poor conditions. So the idea behind the call was that there is continued pressures, hydromorphological, on biodiversity, pollution, and climate change that are causing pressures on the lakes. And this has a potential impact of, say, pushing some of the lakes from the status they are, say, from high to good, or the ones in good from good to moderate, and so forth. So what we're tasked to do in this call was to design and demonstrate an integrated and replicable approaches to protect and restore natural ecosystems and their biodiversity using nature-based and secular-based solutions in lakes, along lake shorelines, or across catchments. And it was clearly, explicitly stated that we should be demonstrating this in lakes that are more than 1 square kilometer. So these are relatively large lakes. So this was the core, what they wanted us to do, and we applied for this. And our idea in FERRO, Olga already has mentioned it. We tried to look at from the problem of the phosphate rock depletion, and also looking at the problem of eutrophication in the lakes, and we're trying to bring these problems together in a way of sustainable lake restoration, which Olga already has highlighted. So who is the FERRO Consortium? The FERRO Consortium is made of 7 partners who are listed, and is coordinated by the UFZ, and we have a budget of 4 million. Duration is 4 years. We started in June 2024. There are 4 academic and institutions and 3 companies, and we have sites in Estonia, Denmark, Germany, and Czech Republic. So now it's time for us to invite 3, or we have already launched our call to invite 3 more partners to join us. And this is also the reason what we are going to talk about today. So just to briefly, maybe just I will rush through this because it's some of the issues that Olga has. So when it comes to phosphorus problems or eutrophication, we know that if there's phosphorus coming from the catchment, it could be from agriculture, urban drainage. It's going into our lakes and it's causing eutrophication. And if we don't do anything, we end up with a turbid state, eutrophic state, and we also have high exports which can get into the oceans. And then the second solution is that we can do some what I would call quick fix restoration, which are more focused more on the lake itself without connecting the problem to the source of the problem. I think this is what we have been doing for quite a long time. It works in some cases, but after some time, we come back to the same problem again. So the idea then is that how can we find solutions that might be a little bit more longer lasting to address this problem? So this is where we come to the issue of maybe sustainable lake restoration, where we are trying to not just look at the problems in the lake, but we are also trying to look at where the problem, where the nutrients are coming from. So in this way, we are combining both agriculture. We are putting agriculture and natural lakes together so that we can find ways of trapping the nutrients before they get to the lakes, or when they are in the lakes, because of legacy nutrients, we are trying to trap them and bringing back to agriculture. But like Olga has said, this is not always possible in most cases. So there are many ways we can do it. But the idea of FERRO is this idea of trying to recycle as much as we can, when we can, the nutrients. So what we are basically doing in FERRO is we want to assess lake vulnerability to eutrophication. We want to restore the lakes using sustainable, secular, and nature-based approaches. And we also want to replicate and scale these solutions, which is the reason why we have been given this cascade funds, so that we could provide some grants to regions which are facing similar problems, and they are keen to use some of the solutions developed in FERRO, or to further develop these methods or adapt them for their regions. So these are the 3 things that we are focused for in FERRO, and we hope this closing this nutrient loop or P loop helps us to deliver multiple benefits that are transcending the local scales. So we have got, so maybe what I haven't mentioned so far is that this core, the Horizon core, was an innovative action. So if you know, innovative actions are more focused on testing or demonstrating solutions, technologies, which are already at a high technology readiness level. So we are doing this in 5 sites in Denmark, Germany, Czech Republic, Estonia. But what I want to highlight in this table is that most of the lakes that we are working on are hypereutrophic or eutrophic, and they have got problems of external and internal loading. And you can see the TP here highlighted in red that is quite high. So in the next part of the presentation, I want to give the opportunity to the FERRO members who are working on these solutions to highlight the solution that they are working on. But first of all, before I move to the solutions themselves, we are going to talk about remote sensing based classification and monitoring, because like I said earlier on, we are working on lakes that are more than 1 square kilometers. And in these lakes, we are also implementing remote sensing. So I'll call upon Petra to give a few words about the next slide. Petra.
Yes, thank you very much. Yes, so this is a part, this is actually work package 4, so it's not a part of the solutions, as Talent mentioned. It's an opportunity to monitor the effects. So it's sort of 2 parts. It could be identifying lakes in need of restoration, so to say if they are eutrophic or hypertrophic or not. And also when actions are made, it's a monitoring technique that could provide data to see the effects of the restorations. So what we are doing in FERRO is that we are providing water quality information that's derived from satellite data, and then we monitor the impact of the restoration activities. And the benefits of remote sensing data, so satellite data, is that it's quite high frequent in time, but also that it has spatial coverage. So you see an example here from Lake FERRO in Denmark. This is from a satellite called Sentinel-2, one image, and this satellite passes over a certain area 3 to 4 times per week, which means that if we have cloud-free conditions, we can quite often get a view of the situation in the lake, and then the whole lake, not just at a sampling point. So it's really a complementary technique to what can be sampled in field. So hopefully new coming partners, we can provide this type of information to support the actions that are made in new demonstration lakes. So what we would like to point out here is in the call, we listed a number of criteria if EO monitoring, so satellite-based monitoring, should be possible. And one of them is the surface area, and it was listed that the lake or the pond should be 1 square kilometer or larger. If you look at the image, we see Lake FERRO, it's quite large, it's 9 square kilometers, but we also see smaller water bodies, 1.2, and we can, the resolution provided by the satellite actually provides even better opportunities, but it also depends on the shape of the lake and such things. So if it's very circular, much smaller water bodies can be observed, but at some point we have a limitation where the resolution of the satellite image data is not enough. So the actual resolution of the satellite is around 30 meters. So 1 pixel element, image element, is 30 times 30 meters. So that's really the physical resolution limitation here. We also need that there are not many islands in the lake or pond because they will ruin the signal. So, and also the floating vegetation. We cannot see the water if there is floating vegetation on top. So this is one of the limitations. So basically, to monitor the water, we need an open water surface around 1 square kilometer or larger, but a bit depending. So the satellite we are using primarily here for the smaller lakes is Sentinel-2, as I mentioned. The data comes from the European Copernicus program, so it's open and free, the data itself. And it has been collecting data since 2015. And there are now 3 satellites of the same type up, so quite good potential for overpasses. What we can see with the satellites is all water constituents that alters the color of the water. So the phytoplankton and the suspended matter and the humic substances are normal suspects that we can monitor. And what you see then below is from phytoplankton, it's then derived as chlorophyll concentration. So you see an example here from Sentinel-2 and a time series from all the cloud-free data that was collected from the monitoring, so the location at the monitoring station of Lake Fyre between 2016 and 2024. So the green dots in the diagrams is from Sentinel-2, and the red dots comes from the in situ sampling made in the lake. So then we can compare and see what Earth observation data can provide. And I would like to say also that for Lake Fyre, this is a quite extensive monitoring program. Many lakes do not have this at all, or just 1 or 2 samples per year. So this is a very good example to be able to compare the different techniques, but when there is less in situ data, Earth observation can really complement the very few samples that exist. Yes, I think that was a short overview of the remote sensing part of the project.
Okay, thank you very much, Petra, for your presentation. So now the next question is Olga highlighted before that there is we can take out the sediments from the lakes and bring them back to agriculture. But one question that can come is, how do we know where the sediments are in a lake? How do we know which place in the lake to take the sediments? So now I want to call upon Thijs Krah from the University of Southern from Denmark to give a presentation on use of sonar technologies. Thijs.
Yeah. Can you hear me?
Yeah, I can hear you. Go
Perfect.
ahead.
So this is just a very short introduction or what we're going to, how we are using sonar. The first here you see is the dredger that Olga already presented from Lake Ormstrup. And the sonar mapping that you see here is side scan imaging that we have been using to verify the dredging, meaning that we can go out and validate more or less where the dredger has been and the effect and the depth of the dredger, meaning that we can take out sediment in a very non-intrusive way, meaning that we won't suspend a lot of material into the lake. And we can validate that we have a total coverage of all of that area that we want to cover in regard to dredging, and even with the depth of the dredger as well. So in principle, what you can see here is that we have some deep dredging tracks, you could call them, where we have tested different types of dredging. And afterwards, this is just like half a year afterwards, we can still see that the sediment hasn't moved around too much in the lake, meaning that we can more or less validate that we can do slow dredging. So we don't have to dredge all the lake in just one go within a few weeks, but we can dredge one area and then come back after a time period and dredge the next area as well. So this is more or less just to validate when we do dredging in the lake with this dredger that everything works according to plan. So what we can see from this side scan imaging as well is that we can see emerging macrophytes that emerge quite rapidly after the dredging, meaning that they're from remnant seeds or dormant seeds in the sediment. But we can also use these kind of images to validate how this dredging can affect the macrophyte dispersal in the lake and see how that will increase over the time course of a year or even across several years, because this is a very rapid method and we can do this just within this lake, can be covered 1-2 hours at maximum. And then we have full coverage of the macrophytes for the whole lake, meaning that we can more or less go out and validate the single macrophyte that we are finding in certain areas just with a rake, meaning that we can also go down to species with different coverage, but also into biovolume. And in principle, from these sonar maps, we get something I would call like a density map of the sediment. And we can use these density maps more or less to evaluate the composition of the sediment. So this is another example from a lake Olga already showed, called Lake Bromme. It's also in Denmark. It's not a very large lake, but so meaning that we can cover this lake in something like half an hour. So the dark brown areas here are softer sediment, while the blue areas are quite hard sediment. And what we can see after the biomanipulation that we have performed in this lake is that the macrophytes start to develop in these areas with quite hard sediment. So these are the areas where we can see the first development of macrophytes in 2019. And 2 years following, in the darker green areas, we have even further development. And we have been following this lake every year until this year, and we can see that the coverage of the macrophytes are increasing on a yearly basis, and we even get charophytes. And in principle, what we have done as well is that we have taken out calls to validate the anoxic phosphorus flux from the sediment, because we know right now in some lakes we have coherence between soft sediment and phosphorus content. In other lakes we don't, but in this lake we don't really have that much of a coherence between phosphorus and soft sediment, but we have a coherence between phosphorus release from the sediment during anoxic conditions and the sediment density. So this indicates that the very soft sediment releases quite a bit of phosphorus during anoxic conditions, while the harder sediments do not release as much. So we can use these sediment maps not only as maybe in some sort of a proxy, but also just to characterize the sediment in different areas as well. And even though we cannot get a direct proxy from phosphorus, this will be very helpful just to identify areas where we could get possible macrophyte coverage, or areas that need stretching because the sediment is very soft. So I think that is a little bit about what we're doing in work package 7.
Okay, thank you very much, Thijs. Now we'll move on in connection to what Thijs has just been highlighting, seeing where the sediments are and taking them out. So Olga now will come again and present on the work that they are doing in trying to use these sediments as fertilizer. Olga.
Yes, University of Helsinki is leading work package 9, which is focusing on sustainable lake restoration by sediment removal and sediment phosphorus recycling as fertilizer. So we explore, we use in fact a quite complex approach. First of all, we explore opportunities of targeted sediment removal, and by combining sediment phosphorus dynamic studies and sonar technology, we are trying to find out areas that can be potentially suitable for sediment removal and sediment phosphorus recycling as fertilizer. And we do the studies in 6 lakes of southern Finland. The area varies from 1 to 5 square kilometers, so this could be a sort of cost-effective and solution with less harm to environment, with less negative harm to environment, also in bigger lakes. And we do this in collaboration with Thijs, in collaboration with the University of Southern Denmark. We have also a real life application of sediment removal in combination with a nature-based solution in the catchment, or we have their sedimentation pond to increase retention and to remove and recycle sediment phosphorus further. And we carried out monitoring before intervention, and we will monitor the lake after intervention to evidence benefits of lake restoration at broader scale. But finally, we also test the fertilizing ability of all sediments collected in the study area and also in our from our experimental side, that will enable us finally to come out with the best practice of sediment recycling as fertilizer. I think that's all.
Thank you.
Thank
you very, very much, Olga. So still with on the topic of reusing the sediments at the University of Southern Denmark, they are doing this, but they have taken a step further by using by also combining it with some biotechnology. So I will invite now Anna-Marie to highlight the work that they are doing.
Yeah, thank you. Can you hear me well?
Yes.
Yeah. So we are doing similar studies as Olga just introduced. So we are also very much looking into the recycling of nutrients from lakes and then to agriculture. So to make use of this quite valuable resource of phosphorus that is stored in the sediments. And we're not only using the nutrient-rich sediment from dredging, but we are also trying to reuse phosphorus that has been captured on the inlets of lakes, and also, for example, from nutrient-rich water from the bottom waters of lakes, and that then has been filtered and temporarily bound to iron-based filter material. And we are looking into to recycle this to agriculture and use it as a fertilizer. The phosphorus in the sediment is known to not be necessarily plant available. So we want to find out and compare to conventional mineral fertilizer how well available it is to plants. And to increase the availability, we are also applying biostimulants to the seeds. So these are bacteria that have been isolated from local soils. And they are then selected by their ability to dissolve phosphorus and coated on the seeds of the crops that we are interested in. So we are also applying this to increase the plant availability of the phosphorus. And to find out about how valuable the sediment, for example, works as a fertilizer, we have established field plot experiments, what you can see in the bottom row of the pictures, where we used the dredged and dewatered sediment from Lake Ormstrup and established field plots to test the fertilizer value of this material and also the biostimulants, how well they work. And we are doing this in large scale, but also, as you can see on the picture in the top, also in small scale in a more controlled environment in lab experiments with pots. So yeah, that's the main purpose of this part of the project, to basically transfer this phosphorus that is a bit annoying in the lakes to a valuable resource and use it in agriculture as fertilizer.
Okay, thank you, Anna-Marie. So up to now, we have been looking at the one component of the lake, which is the sediments. But we also know that the water column itself has some phosphorus. So how do we handle waters that have got the water column that has got high phosphorus level? So I'll call upon again Anna-Marie to explain to us how they are doing this in Denmark.
Yeah. So as I just mentioned, the phosphorus that we want to use in agriculture is not only coming from the sediment, but can also come from, for example, the hypolimnium from phosphorus-rich waters in the bottom of lakes. And the idea here is to pump this nutrient-rich water up to a floating system and then filter the water in a filter that is reusable and where the phosphorus can be recycled then. So can be made plant available and can be reused in agriculture. The goal is to get the lake water that has been filtered to a concentration of below 50 microgram per liter phosphorus, or preferably even lower. And we are also working on to have the system scalable so that it can be used also in smaller lakes and, for example, also in small ponds that have difficult access, if possible. And the demonstration site we are using or working on here is Lake FERRO, that we have heard about from Petra before, in Denmark, close to Copenhagen. It's a deep stratifying lake and a quite big lake. And this lake has been oxygenated for several years and has stored quite a high amount of phosphorus in the sediment. And the idea here is to find or to stop the oxygenation in a controlled way and then to promote the release of phosphorus from the sediment and have an enrichment of the phosphorus in the bottom water, and then to pump it up, this nutrient-rich water, and filter as I have explained before. And again, the focus here is also then on recycling the phosphorus to agriculture and use it as fertilizer.
Thank you very much, Anna-Marie, for that. So now we move on. Up to now, we've been looking at the water body itself, the lake itself, what is already inside. But we all know that these nutrients are coming from the catchment. And we all know that sometimes they are also coming as diffuse from diffuse sources. Where exactly can we implement something? There are many techniques that we can implement in the catchment. But if there are multiple sources, like the diffuse sources of nutrients, sometimes it's difficult to implement something in the catchment itself. So we're looking at this and say, what can we do? So we realized that if a lake has got an inflow, maybe the best point we can try to do something that will cover everything that is coming from the catchment is basically the inflow point. So here I'm showing the work that we are doing here in Germany. It's a reservoir, and as you can see, these reservoirs have got what are called pre-dams or sedimentation ponds, and normally these the two major inflows, which I'm highlighting here. So what we are trying to do is at one of the inflows, we are trying to because this is, as you can see, it's an agricultural catchment. There is a lot of agriculture going on, so diffuse sources of nutrients. So what we are trying to do is we are using ion-based flocculants to we apply them right at the inflow stream before it gets into the into the dam, and we use these flocculants here, and that filters out, or that traps all the phosphorus that is in the water and from the catchment. And as you can see, this is the application here. The picture shows the brown color of the ion flocks that are formed, that are rich in phosphorus. And we do this by, we're having some containers on site and the dosing of this ion flock. So what we have seen up to now is that this works quite well. But now our also focus is on what do we do with the flocks. So the flocks are actually settling at an area which is like maybe up to 50 meters from the point of application. And we are now pumping out these flocks and drying them out. And as you can see in the pictures, and also trying to test their suitability for reuse in agriculture. As you can see, this is from the picture is a clear freedom after the application for about 3 months. And just to give you a quick overview on the results, we did this year already an application for 3 months. And what you can see here is the total phosphorus, and the red line is the inflow that is before the treatment, and the sorry for that, there was an alarm. So the blue line is the outflow area. So you can see during the time we're dosing, we managed to get the concentration of total phosphorus below 20 micrograms, and we managed to achieve this this clear water status that you can see here. And in terms of the reduction, it was 60% reduction in peak concentration, and we also saw that we can recover the flocks, so we can recover the phosphorus. And we think this is an effective midterm solution for lakes, and not only reservoirs, but also for lakes that are affected by diffuse P pollution. So those are the solutions that we're implementing in FERRO. And of course, the goal is to have these multiple benefits. And this is just an overview of all the solutions which you have already seen before. And with that, I want to move on to the next part of the call, which is probably the most exciting for all of you, or what you've been waiting for, which is the FERRO core itself. So so the idea of the FERRO core is, I think this is a fairly new concept for the Horizon Europe projects, that for the projects that are funded now, they also give some money of up to 300,000. that can be used for the cascading funding. So this is what we have just launched this, and the idea for us here is we have shown you different solutions we're implementing, and we know that from your regions you might know of lakes that have got similar problems, and we want you to work with us to try to adapt. It's not a one-to-one transfer because your situation in your region might be different, but we can adapt these solutions so that you can also get some of the results that we are getting already at the FERRO demonstration sites. So there are 3 grants of up to 1,000, and just a quick overview on the timeline. We launched on the 1st of September. Today we are having this call webinar for information and question and answer. The call will run for 3 months until 30th of November. So you have got until 30th of November to make your application. And in December, we'll do an eligibility check. And in January, we do evaluation. And in February next year, we do the decisions. And after that, we'll ask 3 successful candidates to start the sub-grant agreement process, which should be between February to March. And we expect all the successful candidates to start on the 1st of May, 2026, and the projects will run for 2 years until the end of April 2028. So what is the eligibility? We are looking for a local or regional authority with jurisdiction over a natural lake catchment and who are responsible for restoration. They can apply as an individual authority or they can apply as a consortium. And this, if they're applying as a consortium, they can also include universities, companies through a sub-grant, subcontracting option, which I'll talk about a little bit later on. So the idea of these grants is that we spread out as much as we can. So this is the reason why the FERRO countries, the countries that are already part of FERRO are not eligible. So Bulgaria, Czech Republic, Denmark, Finland, Germany, Sweden, and Estonia cannot be part of this. But in general, we are looking for countries that are in the EU or the Horizon Europe associated countries. So we are looking for places where there is a lake, a natural lake, with evidence of eutrophication pressures, and a lake which you think can benefit from some form of restoration based on the technologies or solutions that we talked about. So we also are happy to have candidates who already have had experience with restoration, maybe in that current lake or in other lakes. And for remote sensing, since like Petra already highlighted, we are using remote sensing also for the classification and for the monitoring. So it would be nice if the lakes are at least more than 0.5 square kilometers. But as Petra highlighted, a bigger lake size is better for remote sensing. But we also say that if you have smaller lakes, they are also, we encourage you to apply, and because there are cases also where it can be that there are smaller lakes that need some restoration measures. So we're a little bit flexible there. And then the one important thing is that they should not be overlapping grants. So in the core that we were funded, there are 4 projects that are funded. So FERRO, EuroLakes, ProClean Lakes, and Future Lakes. So Future Lakes and ProClean Lakes already ran their calls. They already selected candidates. EuroLakes will launch next month. We just launched this month. So the idea is that if you have been funded in any one of these calls, you are not eligible. So we don't want overlapping grants. That is a strict requirement. So I'll briefly talk about the eligible activities. We want you to do systems analysis. We want you to implement the FERRO solutions. It can be testing or real implementation, depending on the situation on your region or on your lake. We want you to be involved in like stakeholder engagement. We also want you to use remote sensing applications where possible. And we'll also want you to participate in the FERRO activities, which are meetings, trainings, and events. and to visit the demonstration sites, which you just have heard from our team. So some funding here, financial information. We are going to give 3 grants with a maximum funding of 100,000 per grant. So in total, we've got 300,000, and each grant you can apply. Each applicant can apply for up to 100,000. So this will cover the eligible costs. It will be through lump sum with a 50% pre-financing and 50% on completion of the project. 1 grant per region across. I already mentioned this in the previous, so we don't want overlapping. So we have a subcontracting clause, and a subcontracting clause in this case is meant to allow the authorities to be able to subcontract activities that they cannot do themselves because of not having the expertise or not having the capacity in terms of people to do it. So they can subcontract up to 35% of the amount they are applying. So if they're applying for 100,000, then 35,000 can be set aside for subcontracting, and this allows the research institute and universities to be involved in this core as well. Of course, if your organization is under some restrictions from the EU, you are not eligible. And also, we have got contractual obligations from our side. So the selected beneficiaries are not part of the FERRO grant agreement, but they have to comply with the FERRO grant agreement articles. So we have got articles on conflict of interest, confidentiality and security, ethics and values, visibility, funding statement. This will be shared with the successful applicants, and also they are subject to audits from EU. So this is one of the contractual obligations that are there. Evaluation and selection, what are we looking for? So we are looking at excellence, which is 30%, impact 40%, implementation 30%. And for each, they are broken down into individual points. Like for excellence, we are looking at relevance to objectives, alignment with FERRO and Horizon Europe mission objectives. We are also looking at merit, feasibility, background issues. On impact, we are looking at how much value and expertise are you bringing, and are you going to, is what you are proposing to do here going to have a lasting impact beyond the project, the funding period? And we're also looking at stakeholder engagement. And for the implementation, we look at the work plan. We want clear activities, milestones, and deliverables to be very clear. And we want an appropriate budget and appropriate personnel. And we also want risk management and mitigation plans in. So eventually, for each of these individual items, there is a scale which is highlighted in the documents, which is starting from 1, which is poor, to 5. So for each of these, they will be rated with a 1 to 5, and then that 1 to 5 is depending on your score. Say if you have got 1, that means you get 3%. If you have got 5, you get 15%. If you have got 4, you get 12% of item 1. This is how this is going to be done. The evaluation, our evaluation is an internal evaluation. So we will have 3 evaluators from the FERRO consortium. 2 of the evaluators will be linked to the solution which you want to apply. So if you are going for one of the solutions, then people who are closely linked to that will 2 of them will evaluate, and then there will be 1 independent person from the FERRO consortium, but who is not involved in that solution at all. So basically, 3 people will evaluate, and then there will be declarations of confidentiality and no conflict of interest among those people, for those people who are going to do the evaluations. Scoring is based on the criteria which I've just highlighted with the maximum of 100 points. And the ranking is, we will combine the scores and then create a ranking list. It can be that they are ties. So the first level tiebreaker is a high impact score. The projects or the applicants with a higher impact score will go up. And then if there is again, same impact scores. Then we'll look at the second tiebreaker, which will be the excellence score, and so on. So the outcome is that top 3 will be invited for the contract negotiation. We will also, all the applicants who are eligible will receive a decision email and also an anonymized evaluation report. And of course, the results will be published on the FERRO website. So I talked about eligible activities, but this is also linked to the project tasks. What do we expect the applicants to do? They have to attend the meetings. So the FERRO has one meeting every year, and this meeting, so they have to attend meetings in 2026 and 2027, and also the final meeting in 2028. And we also have sometimes online meetings or webinars. So these new participants are also encouraged to join those demonstration site visits, and also they are expected to do investigations and monitoring and all activities that are related to the systems analysis of their lake or catchment. And they are supposed to co-create and test the solutions with and pilot implementation of the solutions that they are going for. Stakeholder engagement, and also an action plan for the actual restoration of their lake. And also that is during and post project. So in terms of reporting, we'll expect some deliverables reports based on the deliverables you highlight in your application. And we also expect an interim report on month 18 and a final report at the end of the project. And this would be looking at the activities outcomes and also some financial issues. Confidentiality and data protection is important. So we will collect minimum data where necessary, like at the application phase. Basic applicant information will be shared with the European Commission and also maybe the sister projects, because we are also supposed to share information on who has applied among the sister projects. So this information will be shared. Evaluation phase, proposals will be shared with the evaluators, but there are non-disclosure agreements that have to be filled by the evaluators. And of course, the publication of the final list of the successful candidates. Core documents. So you can find everything you need about the core on the FERRO Open Call landing page, which is also in the chat. And you will find there 6 documents, which is the guidelines, which is the more detailed version of how of everything that I have just tried to summarize here. And you also find the application form, and the application form has got some instructions, and you'll find the sub-agreement template. At least for now, that is not important. It's just for information purposes. You will also find a declaration of owner and legal entity form, which are supposed to be filled in and submitted during the application stage. The bank account information form is only for information purposes. It will only be required for the successful candidates. So we encourage you to read these documents and or before you submit your application. On the submission itself, the submission should be in English. So our working language is English, and all submissions should be in English and should be in a PDF format. So we want you to only use the official application form, and you submit through email, and submission deadline is 30 November 2025 at 5 p.m. Brussels times. Late or incomplete submissions or those sent other channels will not be considered. For contact information, you can inform yourself on the FERRO project website. You can visit the FERRO Open Call page. You can also send us an email through this email address if you have got any questions that regarding to your application. We'll be happy to answer those questions. Yeah, so thank you very much for your attention. These are the places where you can find us, including our webpage and our social media. So I open the floor for your questions. Okay, I'm just checking through. Okay, so maybe I start reading the question. During the sediment dewatering stage, during and after dredging, has any of the FERRO work to date looked at trapping phosphorus, other nutrients that may escape groundwater outflow from sediment storage and dewatering? So I guess this is directed to Anna Marie.
Yeah. So the way that it was dredged in Lake Ormstrup in Denmark, dredged and dewatered, was that we used geobags, textile bags, and also flocculants, polymers to dewater the sediment. And then we also had a sand filter system in the end to filter the reject water, which sometimes had quite a high concentration of phosphorus. And that sediment filter was working like semi-successful, I would say, not always, but it's an important point actually to also look at this reject water and trap nutrients also from this to not get them back into the lake. So yeah, we have looked into it a bit, and it's an important point.
And there's another question, sorry, that should have been the first one, from Louise. Can this method be used to remove P in mesotrophic lakes with much lower P concentration too? Thinking SRP in range of less than 20 micrograms per liter. So it's also for you, Anna Marie.
Yeah. Good question. Now, I'm not so much involved into this topic.
I can take that one if it's okay, Anna.
Yeah.
We are currently testing with different concentrations to see if the solution that we are working on can remove phosphorus down to lower concentrations as well. But even in mesotrophic lakes, you should be able to find higher concentration in late summer or early autumn at the bottom waters if you have stratification. But we are working on testing that out during this summer as well, how low we can go with regard to concentration and keeping the high efficiency of the filters.
Okay, so there's another question. I think thank you for accepting us. I have some extra office work during. The question was, is the municipality eligible to apply for this cascade funding? Yes, the municipalities are eligible to apply for the cascade funding. There is another question also from Merrick. Does it have to be a lake? Could it be a lagoon? It has to be a natural system. So a lagoon, if it's a natural system, a lagoon would work as well. Would be eligible. Okay, I'm just checking. I think those were the questions that are in the chat. Are there any questions here? Okay, I think I see another question from Dan. I have a lake. I have a lake we are partially dredging in 2026 with the sediment being spread on arable land, but only 0.25 square kilometers. Will this be ineligible due to the minimum EO size? Petra, would you want to answer before I answer?
I think we should see remote sensing as an opportunity, and it's not stopping applicants if it's not possible to monitor it.
Okay, well summarized. So then we would encourage you to apply because this would also be interesting. Maybe there will be possibilities that we can do something of the with. We'll see what is possible in such cases. Okay, are there any other questions? You can also just open your mic and start your question. It's also fine. Okay, I'll just go through the chat again to see if I have not missed anything. Okay, so they seem to be at the moment no questions, but maybe what I can say is that you have read the documents or you read the documents and you also have had the overview presentations from the FERRO team. And yeah, we encourage you to think about it and make your applications or spread. Yes, Wolf, go ahead. Wolf, is that a question? Okay, I think it was just yeah. So we encourage you to apply and to also spread the word. In the case you are not intending to apply, please spread the word to your networks and to your colleagues. And the recording of this webinar will be shared so that the people who were not able to attend today, they will be able to follow what we discussed today. There is a question in the chat from Saida. Would it be possible for us to apply for funding opportunities related to reservoirs? So this is a little bit tricky because we in the score the focus is on natural lakes. So this is an area where we would want to have the potential applicants being natural lakes. So I would say in this case, reservoirs are not included. Any other questions? Please just feel free, go ahead. It could also be questions to the presentations that we had about the solutions. Maybe you are curious about the experiences from our team. We are also happy to answer those. There is a question from Court. We have a lake, Winkel in Belgium, which is a regatta course for rowing and canoeing. It's 60 hectares surface, but was dug out in 1970. Is that a natural lake? Maybe Court, just to understand, this was what was the status of this place before? Was it just like, was it a lake before, or was it a wetland? What was it before?
It was a wetland. It was agriculture, and then in 1970, around 1970, it was dug out for highways and everything in the neighborhood. But it's like 60 hectares and like 20 meters of depth. So I don't know if it is a natural lake or is it not natural.
So yeah, this is kind of a gray zone. But if it was a wetland before, it can be classified as a natural lake because there are also so many lakes that have been somehow altered in some way. So I would say this would go into the natural lakes that have been altered. It's kind of a gray area, but I would say this could be considered.
Okay, thank you.
So any questions, anything that was not clear, or anything you want to hear from the team, you can also use the opportunity to ask the team members who are working on the different restoration solutions. So I'm just going through the chat. I don't see any. So I give a few moments. Maybe someone typing in the chat. Okay, so it seems we don't have any questions now. Hopefully we've been able to explain clearly what we are looking for in this overview webinar and also in the documents that we produce online. And we want to thank you so much for taking your time to join us today at this FERRO webinar. And we are looking forward to your applications. And in case when you start reading the documents, if you have not read them, if you have got any questions, just write us an email. We'll be happy to answer your questions and guide you through the presentation, the application process. So to all our external guests, thank you very much. And to members of the FERRO team, we can maybe have a short word before we close the webinar. So I wish you, all our guests today, wish you a wonderful day and looking forward to your application. Thank you.